Welcome to this video. In this what we are going to learn is a program 8085 program to count the number of ones in the given 8-bit number. Okay. So let me tell you what is a 8-bit number. This is basically a binary number which contains only zeros and ones. Now for example, if I have got 1 can be written as 00000001. It's a 8-bit number now. Okay, so 5 can be written as, so this is 4, this is 5, so this will be our 8-bit number. The same way, I have written here decimal numbers, but whenever you are giving input to the 8085, most of the cases will be giving it in the form of hexadecimal. So if I write f3, so this f can be written as 1111, and then 3 can be written as 0011. So if you look at this, there are only zeros and ones. In this case we have got 1 in this we have got 2 ones, in this we have got 6 ones. So we have to write a program which will take this number as input, and then it will identify how many ones are present. And this is a very simple program. I'll just explain you how this is going to happen. Now there is some concept of rotations in 8085. This is a rotating accumulator basically. In this question we are going to use RRC. Okay, the meaning of RRC is rotate, write without carry. Means we do not include a carry in the bit. I'll just show you one example. Now let's imagine that I have got this number. I'll just explain you in simple terms. Whenever I have got this value, now this is our 8-bit 11110011. So we'll just try to explain in simple terms. This is a carry. Now the same number will be going backwards. Now if I perform RRC on this RRC, after this performing, you can see that this one will come in C place. Initially if you have 0 1, it doesn't matter, and this place, this one is going to come here. This one means they are going to shift towards the right. 0 1 1 1 1 1 2 3 4 5 6 7, and this one which will be fit into carry also, and it will go back to the 8th bit here. So 1. So you can see when I rotate it, all these elements, all these numbers are moving towards the right. So we'll call it as right rotation, and you can see what is happening in the carry. Carry will take the least significant bit value every time we rotate. Okay, we are going to use the same thing. Now I'll just try to draw a flow chart. So from flowchart you will be able to understand how this is going to happen. Okay, so in the flowchart we are going to start. So when I start, I have to make sure that I will run this particular rotation how many times. You can see how many bits are present here. There are 8 bits. So if there are 8 bits, I have to perform this RRC 8 times, right? I have to perform this RRC 8 times to get it into the carry bit, get everything into carry bit. First time this will come into carry, second time this will come into carry, third time this will come into carry. In this way I have to perform this 8 times. So I have to run a loop 8 times. So if I want to run a loop 8 times, I have to have a variable. That variable keep track of how many times I have run. So if I say that I have got b is equal to 8 times 8, this is basically a iterator, and then I have got c is equal to 0, it means it is a counter value. So we'll just initialize these values. We'll also initialize accumulator value. you have got two possibilities. One, you can do MVI, move immediate into accumulator, or load LDA from the memory. You can do these two things if you want. We'll just see while writing the code how you can use it. Now I have written a number into A. While coding will show you that. We'll just initialize all the values. Okay, we'll just take A is equal to some 0 4, and then B is equal to 8 times, and then C is equal to 0 0. It's a counter. C is a counter. A is the 8-bit number where we are going to identify how it is going to work. And then if you don't want to assign a value, we can just say load A. I can just say load A and then assign this one and this one. When I come here, I'll just check how many times I have run the loop, because here you know that I have to run a particular loop how many times? 8 times. So here we'll check the value of B. B should be greater than 8. This is the requirement. No. See, B should be greater than 0. See, initially B is 8. As you run the loop again and again, after every RRC performing, so after every RRC performing, you have to decrement B. Means this will keep track of your RRC performing. Okay, then if B is greater than 8, if it is yes, then RRC will be performed. It will decrement B, and also it will check if the carry flag, if carry flag is equal to 1, if it is no, and if it is yes. If it is yes, I'll increment C. If no, then I'll go back and I'll just check again B. And if it is no, if B is not greater than 0, if B is equal to 0, what will happen is we'll just directly exit from here and we'll stop it. So it's a very basic program. You can see why I am loading A. It is to take a 8-bit number, maybe from the memory, or read it immediately from the user input. And then second one, this is a iterator. It's going to keep track of all the values, right? All the iterations that we have taken place. Then coming to C is a counter. Okay, C is going to count how many bits are present. You can see if carry flag, I'll write carry is equal to 1. If carry is equal to 1, then only I am going to increment the C. Otherwise, I am going to go back to the main loop once again. Okay. Now we'll just try to execute this part. Now you can see RRC, how many times it will be performed. Every time you check B value and you decrement. If B is 8 here, it will become 7. Go back, yes or no. If it is yes, you can see if it is yes, then also we have to go back to B, right? In this case, you can see even if it is yes or no, I have to run this loop how many times? 8 times. So we have to increment C and then go back to the loop. Okay. Now we'll just try to do this, but one problem while doing this in 8085, we do not have for loops, right? We have to write the loops manually. Now we are going to see this flow chart that we have drawn and we are going to code. Okay, so for that purpose we'll just go to a simulator, which is an online simulator. It is also available for free. It's a free version. What you can do is the first thing, I will try to do this one. I'll initialize a with some value. As of now, I'll use move immediate a with 0 0 or 0 5 h. Okay, and then you can see move some value to b, but I have to ensure that b is equal to 8 because I'm going to run this iteration 8 times. So mvi move b comma 08h 08h mvi c comma 00. It's a counter, so it will be this much. Then after that you will try to write a loop, and this loop will have some operations in it. First one, it is very tricky because we do not have for loop, while loop in this program. So we'll just write a loop, and this loop you can see what it is going to do. It is just doing a RRC. Okay, it is doing a RRC. So in this loop we are going to do RRC, means we are rotating the accumulator right, and then we'll just see decrementing part afterwards. After rotating, we are checking the carry value. So jump if carry, this is jump if carry to increment C. I'll write increment C here, increment C loop. It's a label. In this I'll just say INR C, increment C, right. I have jumped to C. If there is a carry, then I am going to increment C, and after this I'll just try to finish the code. After incrementing C, it is going back to B. I have to decrement B here. So DCR decrement B, and then jump if not 0, means if B is not equal to 0. You can see if B is not equal to 0, it has to go to this loop. So I will go to the loop, and again same thing here, decrement B. You see, this is first case. In this it is jumping to increment C if it is carry is 0. If not, it has to come here. Okay, after doing this one, after running this loop, you can see this is a loop. It will start and it will end here. Only in case of some special cases it is coming here, and again it is jumping back to the loop. So you can see whatever the loop structure is there, it is done. Now when it comes here, if it is 0, if decrement is 0, what happens is it will try to come here and it will execute this once again. To avoid that, what I will do, I'll just put a unconditional jump to exit. I'll say after finishing the loop, jump to exit, and I'll write exit NOP HLT. Okay, just try to execute this code. You can see I have written 5 and I am getting the answer as 2. It means 0 0 0 0. You can see here I'll solve. 0 5 can be written as what? 0 0 0 0 0 1 0 1. So 2 bits. Then next we'll try to run 7. We'll take this 7 and we'll run this. You can see in accumulator C I have got 3. 7 is nothing but 0 7 0 0 0 0 1 1. Okay, 0 1 1 1. You can see this is your 7, answer is 3. So this is working fine. Here there is one more case. Now if you want to load the data from the memory, what you would do? So for loading the data from the memory, you will have to use 2 things. One is LDA and write the memory where you have stored the value. After that, at the end here what you can do, you can move value from C to A. You can move this value from C to A, and then STA means whatever is there in A accumulator, you can move into a memory. Now if in 8001 H, if you have written some value, you will load it into A and you will start this code till here, and after that you will try to move the value into A, and you will store whatever is in the A to the memory back, and then halt. So this is another variant. Here you have got the values in the memory and they will ask you to store the value in the memory. In such cases, what you can do is you can make some modification to the code, otherwise the logic of the program, I think it sounds good. Now in case if it is F and F, you can see it is giving a error. The reason behind this is whenever you are giving first value as a digit, make sure that first value is alphabet, make sure that you will give a 0 here and then execute. You can see in F, you have got 0 0 0, you have got 1 1 1 1 for F, this F 1 1 1 1. So total 8 number of ones are present, so you'll get 1. In this way you can execute the program. Thank you.